In this video, we're going to take a look at measuring what we call arcs of a circle. So first off, we're going to define a new angle. Looking at this circle here with center C, we would call that angle ACB a central angle. It's a central angle because its vertex is at the center of a circle. Also, its sides are each a radius of the same circle. So we say they are radii of that circle. So if you look at the red and the blue portions of this circle, we call these things circular arcs. So those are going to be the focus of this video here. The way that we're going to measure those arcs are going to be two different ways. So we're going to measure the rotation of those arcs. We will also measure the length of those arcs. So rotation is really just measured by the central angle. So if I was to look at that red arc from A all the way along that circle over to B, the rotation of that arc is equal to the rotation of my central angle. Now, if I wanted to look at the rotation of the other arc that goes from A and then passes through D along the way to B, I would have to do 360 minus the measure of that central angle, because that other rotation adds up to the remaining part of 360. So notice the naming here. That red arc I name with just 2 points, A and B, with this little arc symbol above. The blue one I name with 3 points. That indicates that I traveled a longer path. We're going to classify these here in just a minute. So the first way to measure arcs is rotation. That really just has to do with the central angle that corresponds to that arc. The second way is length. So it's just going to be a portion of the length of a circle, which is circumference. So we're going to use this formula. This is called arc length. So the arc length of any arc is going to be a fraction of circumference. So the way that we get that fraction is we just take the angle that we're looking at and divide by 360. So angle over 360 times circumference. That'll give us a fraction of the total length of a circle, which is just circumference. So just remember circumference, that's 2 pi r, or pi times diameter. So those are the two ways we're going to measure arcs. The way that we're going to classify arcs are three different ways. We're going to look at minor, major, and semicircular arcs. So it all has to do with how much rotation they have. So that first arc, AB, that I mentioned with just 2 points, that red one, that has a rotation that is less than 180 degrees. So we're going to call that a minor arc. We're always going to name minor arcs with just 2 points, those endpoints. Now, major arcs, they're going to have a rotation that is more than 180, but less than 360. And to indicate a major arc, just according to its name, we're always going to use 3 points. So that's kind of why up here I have ADB that represents that blue arc versus just AB would be the red one. The last type of arc is called a semicircle. That's just when we have a rotation equal to 180. So that's going to be when you have a diameter. We will also use 3 points to name semicircles. So that's actually kind of important. We'll talk about that in class. Lastly, we're going to look at how we can relate arcs. So we're going to have arc congruence, just like we have congruence of other things. To be congruent, two arcs have to be either in the same circle or congruent circles and have the same rotation. The reason why is because we measure arcs two different ways according to their rotation and their length. For things to be congruent, all of their measurements have to be the same. So that's the reason why we need to have the same or congruent circles and the same rotation. That would make both their rotation measurement equal and their lengths equal. You can actually have two different arcs that have the same rotation but different lengths. Just think of a smaller circle versus a bigger one. Lastly, we're going to add the measures of arcs together. This is really just the same as the angle addition postulate. This is called the arc addition postulate. So if I take two adjacent arcs, like arc AB and BC, those are both minor arcs. If I add their rotations, I get the rotation of arc AC. So that's how we're going to use basically the angle addition postulate, but in the context of circular arcs. That should do it for 10.2.